a bicycle going around a circular track. It's on an angle, but it's still centripetal motion. It's in a circle. Centripetal motion. Alright. We've got the radius here, 20 metres, speed of 15 metres per second, and the mass of 300. What's the magnitude of the total force on the bike and rider in a circle? The total force equals mv squared on r. Which, when you put the numbers in, is 300 times 15 squared on r20. With your calculator you should get 3375 newtons. Goes with 3.5. Same question, sorry. New one. Question 5. Alright, again I've photocopied the diagram up here so we can see it. Next one. Figure 2b shows that only two forces act on the rider. One's the gravity force and one's the normal force, or the reaction force. On figure 2b, draw an arrow to show the direction of the net force, the total force on the bike and the rider. Explain how these forces cause the net force. There's two ways, well, there's only one answer. Another answer that people, I'm just going to draw a man instead of a bike. Another answer that some people had put is something like this, down the ramp. This will cause the cyclist, this is my man on a bike, to roll down the ramp as opposed to going around in a circle. Right. The actual way these add together is into the, let's make a nice straight line here, into the middle. And you have to explain how the forces cause this net force. And it's just going to say, why do those two equal that? And all we're going to do is forces add as vectors. So if I was to add these, I always add them head to tail. So that plus that equals, let's draw the first one here. Alright, the head of the first, so the tail of the second, so the tail goes there, tail, and you've got overall force that way, which is what we've got there. Again, copied and pasted, and this is the sixth question, or the third question in the series, but question number 6, what's the correct angle to achieve the net force that we've got? So, the formula for this, for banked things, or even if we've got a pole and a ball swinging around, that game, is that tan theta equals net force over mg, and if we had to put the values in, it's mv squared over r over mg. Now we've calculated this before, the net force 3375, and I've got a mass of 3000, so mg must be, so I've got a mass of 300. I'm jumping ahead, then 300 times 10 is 3000. That equals 1.125, and that's tan theta. Tan theta equals 1.125, so to rearrange that, theta equals inverse tan of 1.125 on your calculator, comes out at 48.3 degrees.